protein beverages, because this will be my first matrix that I'm going to test the vitamins in. So looking at my protein beverage formulation, I'm going to have a whey protein, a vanilla flavor, and then I'm going to have a vitamin premix, either encapsulated or unencapsulated. The encapsulation refers to I'm either going to have a starch or a fat coating on the vitamin to help protect it from degrading over time. Looking more at the experimental design, I'm going to have a negative control, which I'll just have the flavor and protein. I'm going to have a ready-mix protein beverage with unencapsulated vitamin premix. So it'll just be protein, flavor, and unencapsulated vitamin. And then I'm going to have protein, flavor, and then an encapsulated vitamin premix. We're going to store these 3 beverages at 2 temperatures, 21 degrees Celsius, which is room temperature, and 35 degrees Celsius, which is representative of if a consumer just throws it in the back of their car, kind of the vitamin stability that would occur. These protein beverages are going to be stored for 9 months, and they're going to be sampled monthly. Looking more at the analysis that each sample will undergo, each sample will undergo vitamin analysis via the UPLC. We're going to do descriptive analysis on each sample to track those flavors, and then we're also going to do volatile analysis. Looking more at the UPLC methods, we're going to be doing 2 extractions on these ready-to-mix protein beverages. We're going to be extracting all of the water-soluble vitamins from it, and then all the fat-soluble vitamins from the ready-mix protein beverage. We're then going to quantify the water-soluble vitamins with 2 UPLC methods versus the fat-soluble vitamins. We are able to quantify them in 1 method. Looking more at the water-soluble vitamin extraction, we're going to have 8 grams of ready-mix protein powder. We're going to rehydrate that in water. We're then going to use TCA to do a protein precipitation, and then we're going to centrifuge it and then take the solid and separate the acid extract and the solid, and we're going to repeat the extraction and then we'll run the acid extract on the UPLC to see how the water-soluble vitamins are degrading over time. Looking at the fat-soluble vitamin extraction, we're going to take 10 grams of ready-mix protein powder. We're going to rehydrate it with ethanol and KOH. We're then going to flush the sample with nitrogen and then do an 8-hour saponification process at room temperature. We're then going to do a hexane extraction the following day to extract all the fat-soluble vitamins. We're going to do this in triplicate and then dry the hexane extract under nitrogen. The residue will then be rehydrated in methanol and then run on the UPLC. We're also going to do descriptive analysis using our established whey protein lexicon. This is just the whey protein lexicon that we do in our lab, and we're just going to track off-flavor development over time. And we're also going to be checking neutral aldehydes and vanillin flavor developments over time using gas spectrometry, mass spectrometry. So the key deliverables for this dissertation is going to be a quantitative understanding of vitamin stability in protein bars and beverages. And we're hopefully going to be able to identify sensory and volatile compound markers of protein bars and beverage stability and give insight to how that affects consumer preferences and how they change over time. At this time, I would like to acknowledge Glanbia, the Sensory Service Center, and Dairy West for funding this research.